Hello there students and welcome back to this video series. This is your instructor Dhruvi Bhatt and today we would be talking about break-even analysis. In the previous lecture, we understood about different types of costs. We understood that there are basically two types of costs, short-run costs and long-run costs. We would be discussing the use of some of the costs here in this video. So those who have not referred to the video of types of cost, please go through that before you go through this video, because only then you will understand some of the terms. Starting with first things first, what is meant by break-even analysis? What exactly is break-even analysis? Break-even analysis is an analysis to determine break-even point. What is break-even point? A point where the revenue received exactly equals to the costs associated with receiving the revenue, which means that my total investment is exactly equal to my revenue. We can, in simpler language, say that break-even point is a point where there is no profit and no loss. Here I have received back my investment. Now onwards I will receive profit. Before break-even point there was loss. After break-even point there will be profit, and the point at which there is no profit and no loss is known as break-even point. The analysis conducted in order to find this break-even point is known as break-even analysis. Here in technical terms we can say that at break-even point our total revenue equals total cost. My total revenue exactly equals the total cost of production. These are two separate terms. Revenue you will receive by selling your products, and cost is cost of production, which includes your cost of raw materials, cost of buildings, cost of machineries, cost of laborers, etc. All different types of costs which we studied in our previous lecture. All those costs account for total cost. Okay. Students, break-even analysis is also known as cost volume profit analysis or CVP analysis. This is the another term for break-even analysis, cost volume profit or CVP analysis. It is dependent on the sales volume, the selling prices, the fixed cost and the variable cost, and of course the profit. So break-even analysis would be dealing with all these different things. Before understanding the role of each of these in break-even analysis, let us first understand some of the assumptions of break-even analysis. Which are those? The first assumption of break-even analysis says about relevance range. It tells us that the company is operating in a relevant range. Remember students, break-even analysis is only true for a relevant range. This means it is only true for short run production. From previous many lectures I am telling you that short run is a period during which the capital of the company remains constant, which means the fixed costs remain fixed. If your capital does not vary and only your labor varies, then the corresponding range is considered to be the relevant range for break-even analysis. The second assumption is for fixed cost. It says that total fixed costs are assumed to be constant. Total fixed cost, which is TFC, is assumed to be constant. What about average fixed cost? Average fixed cost is total fixed cost divided by Q. So as number of units increases, the average fixed cost will decrease. The third assumption is regarding the variable cost. Variable costs per unit are assumed to be constant, which means that variable cost for producing a single unit is assumed to be constant. Say, for example, for producing one pencil, my cost is 5 rupees. My variable cost is 5 rupees. Then for producing 5 pencils, my variable cost will be 5 into 5 is equal to 25 rupees. Which means the average variable cost or variable cost per unit is constant, but total variable cost will increase with increase in production or increase in number of units produced. Remember this. Our fourth assumption talks about sales revenue. It tells us that sales revenue per unit is assumed to be constant. What is sales revenue per unit? Obviously the selling price of the unit. We are talking about pencils here, then selling price of one pencil will be constant. Say if I sell one pencil in 10 rupees, then for selling 10 pencils, my total revenue is 10 multiplied by 10 is equal to 100 rupees. You got me right there. Here they are telling us that the total revenue per unit is assumed to be constant, and the total revenue will obviously increase with increase in production, increase in number of units. Our next assumption says that all the units produced are sold. We are assuming here that everything, whatever we produce, is sold. This is the only way to find break-even analysis. And students, mind you, this is an assumption. Obviously, there can be a scenario where everything you will produce may or may not get sold. This is the best case or idealistic condition in which we try to calculate the break-even point, where we will be assuming that everything, whatever we produce, gets sold. Our next assumption says that there are no change in prices. The selling price does not change. There is no increase or decrease in prices. There is no premium charged on the price. Neither there is any discount charged on the prices. The prices will remain same throughout the tenure of break-even analysis. The next assumption says that there is no change in technology and efficiency of labor. Why this assumption? Students, if technology changes, then your fixed cost will vary. If technology changes, then you will purchase new capital or new instruments to adapt that changed technology. Then you will not remain in short run. That is why it is assumed that in this short run, technology is not changed and efficiency of workers is also not changed, which means workers charge you the same money and produce the same number of units time and again. The next assumption says that this break-even analysis holds true only for a particular product. For each and every product, the break-even point varies. So, once you carry out break-even analysis, it is true only for that particular product and not other products. The last assumption is very interesting one, which says that there are no taxes. We are not considering any additional costs which we will incur as a producer. So, here we are assuming that we are free from taxes. In a different universe maybe, but this is the assumptions of break-even analysis. Kindly remember it. Firstly, you must remember it is in short run. Short run is the period where your fixed cost will remain fixed because there is no change in capital. Total fixed cost remains constant. Average variable cost remains constant. Sales price or revenue per unit remains constant. There are no taxes, no change in technology, no change in efficiency of laborers, everything produced gets sold, etc. Remember all these assumptions and we will move forward to understand and draw the break-even chart. In order to draw the break-even chart, I will present to you some values. Here students, as you can see, the number of units produced are given. Starting from 0, we have 1, 2, 3, 4, 5, 6 units produced. Let us take the example of pencils itself. When 0 pencils were produced, what are the different values of all these concerned factors to break-even analysis, which we will show in break-even chart, that we need to understand. First, we will understand the term total fixed cost. As we assumed, the total fixed cost remains constant. If you remember, fixed cost is the cost which remains constant irrespective of number of units produced. So here, irrespective of number of units produced, the total fixed cost will remain constant, which is 10 rupees. If you can view it in this table, the total fixed cost remains constant and say it is 10 rupees. Whether I do not produce a single pencil or I produce 6 pencils, the total fixed cost is 10 rupees. Let us try to plot this on a graph. Obviously, in this graph, we will get fixed cost as a straight horizontal line parallel to x-axis, because here we have a graph of number of units to the total fixed cost. So at each and every number of unit, my fixed cost remains constant. So I'll get a line which is parallel to x-axis. This line shows us the total fixed cost. Remember this. Moving forward, let us understand some other quantities. What is the average variable cost and total variable cost? If you remember our assumptions again, our average variable cost or variable cost per unit will remain constant. Irrespective of number of units, the variable cost is say rupees 5. Irrespective of number of units, my variable cost is rupees 5. But total variable cost will increase with increase in number of units. If for producing one pencil, my variable cost is 5 rupees, for producing 0 pencils, my variable cost is 0 rupees. For producing 2 pencils, it is 10 rupees. For producing 3 pencils, it is 15 rupees, 3 into 5. I hope you are getting this. We are just multiplying the quantity of pencils with average variable cost, which is constant. So for producing 6 pencils, I'll get a total variable cost of 30 rupees. How this graph would look like? Let us see it in the graph itself. Students, here fixed cost remains constant. This is the graph of total fixed cost. With number of units, it remains constant. But with number of units, total variable cost increases. So I must get an increasing graph. At 0 pencils, my total variable cost was 0. At 1 pencil, it was 5, 10, 15 and so on up to 30. This is the graph for total variable costs of pencils. Let us move further and understand one more quantity, which is total cost. If you remember from the previous lecture, our total cost is just the addition of total fixed cost and total variable cost. And even if no units are produced, there will be some total cost, because total fixed cost is equal to 10. Though I got total variable cost is equal to 0, I'll get total cost is equal to 10, because it will be 10 plus 0 is equal to 10. Similarly, here we have TFC plus TVC, total fixed cost plus total variable cost, 10 plus 5, 15 and so on, 20, 25, 30, 35 and 40. Let us check this in the graph. Obviously, it will be an increasing graph. This is our total fixed cost. This is our total variable cost. Total cost will be again an increasing line, but starting from the point of total fixed cost. Very good. This is the line of total cost. It starts from the point of total fixed cost, because apart from total variable cost, we are trying to add the fixed cost in that, and that is why it increases and moves towards the upper side of the line of total variable cost. Moving towards the last quantity, which is total revenue. As we discussed in the assumption, my selling price or total revenue per unit remains constant. Say for example, my selling price is 10 rupees. Say for example, my selling price is 10 rupees, then my total revenue will increase with increase in number of units. If I sell 0 pencils, my revenue will be 0 rupees. If I sell 10 pencils, My revenue will be 10 into 10 is equal to 100 pencils. Here I have given total revenue for 6 pencils. For 0 pencils it is 0. For 1 pencil 10. For 2 pencils 20. For 3 pencils 30 and so on up to obviously 60. Let us check this line in our graph. This is our graph again. This is my total fixed cost, a line which is parallel to x-axis. My total variable cost, which is a line with an increasing or positive slope. My total cost, which is the line which is much above the line of total variable cost, because we add total fixed cost to total variable cost to get the total cost. And finally, the line of total revenue. Finally, the line of total revenue. It is again an increasing line with a positive slope. Okay, students, in this particular table, can you find break-even point for me? If you remember, break-even point is the point where your total cost equals your total revenue. Can you find any such row where my total cost and total revenue are equal? If you observe closely, at this point at 2 units, we have our total cost and total revenue to be equal to 20. Thus, this is the point which is break-even point for our one product pencils. For my manufacturing unit of pencils, my break-even point is of 20 rupees. Again, students, we have done assumptions in these numbers. These are very small compared to the actual numbers in any manufacturing unit. For your easy understanding, I have taken such example. Okay, let us try to check out this break-even point in our graph. The point where my graph of total cost and total revenue intersect, that point will be break-even point. This is the point where you are selling 2 units and your revenue is of 20 rupees. What about before this point and after this point? As I already told you, before this point we are facing losses. Check this out. My total cost is 10 rupees, but my revenue is 0 rupees when 0 pencils are produced and sold. My total cost is 15 rupees, but my total revenue is only 10 rupees when only 1 pencil is produced and sold. So before break-even point, we have an area which showcases losses to us. In the graph, this particular area is given below the break-even point. Remember this, below the break-even point, the area of graph shows us loss. What about after break-even point? After break-even point, you can see that my total cost is 25 rupees, but my total revenue is 30 rupees. I am making a profit of 5 rupees. Here my total cost is 30 rupees, but my total revenue is 40 rupees. Here my total cost is 35 rupees, but my total revenue is 50 rupees. At all these points, I am making profit. This area below the break-even point in this table shows us profit, and this will be shown in the graph above the break-even point. At all these points we have profit, and below the break-even point we have loss. Remember this, the point where the graph of total cost and total revenue intersect is the break-even point. The quantity at break-even point, which is 2 units, is known as break-even quantity. The revenue at break-even point is known as break-even revenue or break-even in terms of rupees, which is 20 rupees. Before break-even point, we have loss. After break-even point, we have profit. Okay, students, let us understand some of the derivations for the break-even point and try to identify how to derive it. Okay, students, break-even point, as I already told you, is when your total revenue is equal to total cost. If you can identify from the table, how did I calculate total revenue? I told you that if for one pencil the selling price is 10 rupees, then for 5 pencils the total revenue is 5 multiplied by selling price, which is 10, which is equal to 50 rupees. So here, can I say that total revenue is actually the quantity multiplied by selling price? This is the total amount of money a firm receives from selling goods and services. As I told you, it can be given by Q into SP. So we have the formula here that TR is equal to Q into SP. Then what about total cost? Total cost is the total amount of money a firm spends in making goods and services. Obviously, students, as discussed in previous lecture, the total cost is the addition of total fixed cost and total variable cost. We have total cost to be addition of total fixed cost and total variable cost. These are the two formulas which we will substitute on both these sides to derive the formula. For total revenue, we have Q into SP. For total cost, we have TFC plus TVC. Now, we will derive break-even point in two ways. As I told you that the quantity at which the break-even occurs is known as break-even quantity or break-even point in terms of units. The revenue at which break-even occurs, which was 20 rupees, is known as break-even in rupees. First, I will try to derive break-even point in terms of units. After that, we will try to derive break-even point in terms of rupees. To derive break-even point in terms of units, we will start with the initial condition where our TR is equal to TC or total revenue is equal to total cost. But we understood just before a minute that TR can be substituted by Q into SP and TC is actually TFC plus TVC. Now students, if you remember, we assumed that your average variable cost remains constant. If you check out, your selling price remains constant, your total fixed cost remains constant, but your total variable cost isn't constant. What is constant? Your average variable cost. If average variable cost is given, then how can I find total variable cost? We have average variable cost is equal to total variable cost divided by Q. We studied this in the previous lecture, and also in this lecture I told you that if for producing 1 unit my average variable cost is 5 rupees, then for producing 5 units my total variable cost will be 5 into 5 is equal to 25 rupees. So can we say that AVC is equal to TVC by Q, which will give us total variable cost TVC is equal to AVC multiplied by Q, average variable cost multiplied by number of units. Replacing this in our equation, we have Q into SP is equal to TFC plus Q into AVC. Let us take the terms having Q on left hand side. We will get Q into SP minus Q into AVC is equal to TFC. So I can say that Q into SP minus AVC is equal to TFC, which will give me Q is equal to TFC, total fixed cost, upon SP minus AVC, which is selling price, minus average variable cost. What is this Q? Number of units where TR is equal to TC is known as break-even point. This is nothing but break-even point in terms of units, which is TFC divided by SP minus AVC. Remember this formula. The denominator in this formula is termed as contribution. SP minus ABC is known as contribution per unit. What is the contribution of this unit in total profit? Selling price minus average variable cost. Because fixed cost remains constant, we will have the contribution to be SP minus ABC. Remember two things from this slide, students. Break-even point in terms of units is equal to TFC upon SP minus ABC, and contribution is equal to SP minus ABC. Let us check out the derivation for break-even point in terms of rupees. What is break-even point in terms of rupees? Students, I got number of units at which break-even occurs. If I tell you that when I sell 2 pencils, break-even occurs, and the selling price of each pencils is 10 rupees, what will be the break-even point in rupees? You will just multiply these two quantities. I will multiply 2 pencils multiplied by its selling price, which is 10. I easily get that 20 rupees is the break-even point in terms of rupees. Can I say that break-even point in terms of rupees is Q multiplied by SP? But at break-even, we got Q is equal to TFC upon SP minus ABC, and as I told you, BEP in rupees is equal to Q into SP or BEP in units into SP. We will have thus BEP in rupees is equal to TFC upon SP minus ABC multiplied by SP. Students, if break-even quantity is directly given to you, or if you reach break-even quantity in some manner, you can directly calculate break-even point in rupees by the formula break-even point in units into SP. Remember this. If you can find break-even point in units easily from the question, you will find break-even point in rupees by the formula break-even point in rupees is equal to break-even point in units multiplied by selling price. But if you cannot reach break-even point in units due to the given quantities in the problem, then we will need to derive this formula further to find break-even point in rupees. Just to make sure that in some cases where you are not directly given the values of TFC, SP, ABC, etc., and you cannot find those values, you will need to calculate BEP in rupees with some other formula, which we will derive just now. As you can see here, students, that BEP in rupees is given by TFC upon SP minus ABC multiplied by SP. Can I take this multiplied by SP into denominator? Yes, I can easily take, and that is what I have done. I have taken that multiplied by SP into denominator of denominator. Okay, so I have TFC upon SP minus ABC upon SP. Let us try and multiply and divide the denominator by Q. We will multiply and divide this denominator SP minus ABC upon SP by Q. Let us see what happens. It will leave us with TFC upon SP minus ABC upon SP the whole multiplied by Q by Q. If I try multiplying Q inside, I will get TFC upon SP into Q minus ABC into Q upon SP into Q. If you remember, what is Q into SP? Q into SP is your total revenue or TR. What is Q into ABC? Average variable cost multiplied by number of units produced is total variable cost. Can I replace this? We have SP into Q is equal to TR or total revenue, and Q into AVC is equal to TVC. Replacing that in formula, BP in rupees is equal to TFC upon TR minus TVC upon TR. Remember this formula. In this formula, the denominator TR minus TVC upon TR is also known as contribution ratio or profit to volume ratio, which is P by V ratio. Remember this thing, students. Our denominator TR minus TVC upon TR is known as contribution ratio or P by V ratio or profit to volume ratio. Hence, we can conclude that BP in rupees is equal to TFC into TR upon TR minus TVC. You can let that TR remain in the denominator of denominator, or you can bring it in the numerator as per your will and wish. Remember this formula that BP in rupees is TFC upon TR minus TVC upon TR. Fair enough. We are left with the last derivation, which is the derivation for number of units produced in case there is some profit. In a case where you are asked a question that how much units must be produced to earn a profit of 60 rupees. You saw in the table that to earn a profit of 60 rupees, 6 pencils must be produced. But how to find that particular answer if no such table is given? For that, we will go through some derivation. What is the formula for profit? Profit is simply given by TR minus TC. We have studied from very initial age that profit is equal to selling price minus cost price. But if we talk about the total sales, then we will need to talk about the total cost. So here my profit is equal to total sales or total revenue minus total cost. We have the formula for both TR and TC, where we have TR is equal to Q into SP and TC is equal to TFC plus TVC. Also we have TVC is equal to Q into AVC. Replacing all such things in our formula for profit, where profit is given by TR minus TC, we have profit is equal to Q into SP minus TFC plus Q into AVC. Taking the terms together with Q in them common, profit is equal to Q into SP minus TFC minus Q into AVC. Taking out Q as common, Q into SP minus AVC minus TFC. So, taking TFC to the side of profit, we have profit plus TFC is equal to Q into SP minus AVC. We need to find Q here, number of units to earn specific amount of profit, number of units to earn specific amount of profit. Making Q the subject of equation, we have Q is equal to profit plus TFC upon SP minus AVC. You find the formula a little similar to the break-even point? Yes, students, it is similar to the formula for break-even point. Just place profit is equal to 0. If in this equation profit is equal to 0, then TFC upon SP minus AVC is the formula for break-even point in terms of units or quantity. So, if some profit is given to you, to find the number of units produced to achieve that profit, we have the formula Q is equal to profit plus TFC upon SP minus AVC. Remember all these formulas. We will be solving some numericals in our next session. Until then, thank you so much for such patiently listening to me. This is your instructor Dhruvi Bhatt signing off. Until next time, bye-bye.